Today we are going to talk about future development of prosthetic arms. The prosthetic arms we see in recent years are worked by harnessing shoulder power. So when you squeeze your shoulders, they pull on the bicycle cable, and that cable can open or close a hand, or a hook, or bend an elbow. And we still use them commonly because they are very robust and relatively simple devices. The state of the art is what we call myoelectric prostheses. These are motorized devices that are controlled by little electrical signals from your muscle. Every time you contract a muscle, it emits a little electricity that you can record with antenna or electrodes and use that to operate the motorized prostheses. They work pretty well for people who have just lost their hand because your hand muscles are still there. You squeeze your hand, the muscle contracts, you open it, so it's intuitive and it works pretty well. However, that kind of prosthetic arms have to be used with our eyes vision. We can't control them without a look. That is because we can't feel while the robotic hand is touching things. You don't know whether is it holding something or not. In order to overcome this issue, Applied Physics Laboratory at Johns Hopkins University, the main chief engineer Dr. Mike McFlynn and his team have been working on prosthetic arms that can controlled by the mind and also arms that could feed back. This project was launched by DARPA, Defense Advanced Research Projects Agency. They made a robotic arm called Modular Prosthetic Limbs, or you can call it MPL. It interprets and converts signals from body nerves system to motions, and when MPL interacts with the object, signals from 100 sensors send information back to the brain, creating a sense of touch. They have cooperated with another biological team which was doing sensory renovation surgery. That is, finding a nerve that gives a signal of touch to the brain and reattach them to the amputee's skin, so the sensor will be able to send the signal from the brain by attaching to the skin. The user of the robotic arms will have to wear a sensor on their limbs in order to get the signal from the brain, and at the same time, that sensor could create light pulse to the nerves that are on the skin, so the nerve will send the signal back to the brain, creating a sense of touch. Prosthetic arms that we just talked about, you need to proceed a difficult surgery, so the machine could work. What if I don't want to do the surgery, or I don't have enough money to do the surgery? Is there any other way to make the prosthetic arms to move the way I want? A 19-year-old inventor came up with a truly remarkable robotic limbs. He designed and built his own robotic arm with a 3D printer. The special part of his prosthetic arm is that it doesn't need to be contact to the arm or the chest. So how do you make it move the way we want? The answer is brainwave. It starts with a simple game called Mindflex, which allows players to control a ball using the power of their mind through a device wearing on player's head. He took the game apart, seeing how different movements were linked to particular brainwaves when humans move their hands, and then translated this special pattern into his robotic arms. It ended up that people could command the hand open or close by thinking without touching the robotic arms. These technologies brings the way we look at prosthetic limbs to a whole new level. In the non-far future, maybe you will be able to build an arm that is more similar to real human hands or even better.